Hi everybody, welcome back. Glad you could tune in again. So we've been thinking about aspects of the world around us which the secular, reductive, materialist outlook on the universe cannot explain, but which Christian theism can explain. We've talked about the mind, we've talked about our moral and ethical sense and so on. Let's talk today about the entire universe, the universe as a whole. Because it turns out that a secular, reductive, materialist view of the cosmos cannot explain how the universe even came into being, certainly not with the kind of properties that this universe now has, allowing it to support life and to support our existence and so on. To put it another way, the Christian theist can explain how we got here. The secular, reductive materialist cannot even explain how the universe exists in such a way that we are able to be here. And to explain this, what I want you to do is to imagine for a second that you are a reductive materialist. Think what that would entail for your view of the world, and then let's see if that works. The standard cosmological model, which is held by almost all reductive materialists in the scientific community, says that the universe came into being about 13.7 or 13.8 billion years ago, started with the Big Bang, and the matter that came from the Big Bang has been moving outwards into and creating the fabric of space and time ever since that moment, that it's condensed into systems of galaxies and then individual stars and some planetary systems and so on, and that's where the cosmos came from. Now, in order to understand the difficulty that reductive materialism has in explaining that process, we need to understand a little bit about how physics describes the behaviour of matter in the universe. To simplify just a little bit, at the most fundamental levels, physics says that the behaviour of all matter can be explained and described by a fairly small number of physical constants. These are numerical values which set the size of the fundamental forces of nature, things like the gravitational force, electrostatic forces, the weak nuclear force, the strong nuclear force, and so on. And it turns out that the values of these forces have to be extremely precisely tuned, both in themselves and in relation to each other, in order for the universe to function at all. Now, that fine-tuning argument is not something that's unique to Christian theists or secular reductive materialists. All physicists recognise that the physical constants have to be extremely finely tuned. The question is, how did they get to be so finely tuned? And of course, the secular reductive materialist has to say, well, it's random. In the end, it's just the way it is. And so it's worth asking ourselves how probable or improbable those numbers are if you think they came about by chance. Let's think about the relationship between some of these significant values in nature and try and work out how likely we think it is that these factors came about by chance. Just a simple example to start with, and this isn't really such a fundamental force, but it's an intriguing one anyway. It turns out that the ground state energy levels of beryllium and helium nuclei would have to be within about 1% of their present value in order for the universe to contain any carbon. If you tweaked those energy levels in those two nuclei by just 1% in relation to each other, you'd have no carbon, and therefore it's very hard to see how you'd have any carbon-based life, like you and me. But that is small beer compared to some of the more esoteric numbers which we're going to encounter in a moment. Think of some of those fundamental forces of nature. It turns out that the relationship between the strong nuclear force constant and the electromagnetic force constant has to be tuned to where it is to a precision of about 1 part in 10 to the 16. And if it's not, the universe will contain no stars. Now, 10 to the 16 is kind of a hard number to get your head around. 10 to the 16 is 1 with 16 zeros after it. And you've got to imagine yourself with your hand hands on two dials trying to control the outcome of the creation of the universe by how you tweak these dials. And if you tweak them ever so slightly, like by 100 millionth of 1%, boom, the universe contains no carbon at all. The secular reductive materialist has to say, well, that just happened by chance. But that's fairly insignificant compared to the next example I want to give you. The ratio between the electromagnetic force constant and the gravitational force constant has to be tuned to within 1 part in 10 to the 40, or the universe will contain only large stars or only small stars. Turns out that, according to the standard cosmological model, again, you need large stars to create heavier elements, but small stars to burn long enough to allow planetary systems to form, and so on. So if you don't have the numbers of those two constants tuned with that degree of precision, then you're not going to have a universe that can sustain planetary systems and life. So you've got your hand on the dials, you imagine yourself as the creator of the universe, and if you're a secular reductive materialist, this is happening randomly, and you have to get those two dials tuned to within 100 billionth of 1%, 1 part in 10 to the 40. Now, most people have no conception, myself included, really, how astonishingly, breathtakingly vast a number like 10 to the 40 is. So I think here's an illustration to help you. I want you to imagine getting a quarter out of your pocket, like a little coin, a little silver coin, and lay it on the floor, and then go find your big brother or your little sister or something and put another quarter next to it, and get as many quarters as you can. Keep putting quarters on the floor until you've covered the whole room, and then keep going until you've covered all the street on which you live, and all the whole of the surface area of the town in which you live, and then keep going until you've put a single layer of coins, little quarters about that big, all over the whole continent of North America. And then do the same thing again, put a second layer down on the entire continent of North America. Just think of the plains of western Texas. You're covering it with quarters, 2 layers deep, 3 layers deep, 4 layers deep. Keep covering America with coins, the entire continent of North America with coins, and keep going until your pile stretches to the moon. You now have a pile of coins that's the size of North America and stretches all the way to the moon. And then do the same thing again, and again, and again, and again, until you've done it 1 billion times in total. You have 1 billion piles of coins, each of which is about the size of North America in width and stretches from the Earth to the moon. And now paint one coin red and hide it somewhere in one of the piles, and blindfold your big sister or your little brother and ask them to pick it out randomly. The chance of them getting it right first time is about 1 part in 10 to the 40, which is how accurate the Creator's aim would have had to be in order to get the universe that we currently live in. Or, if you're a reductive materialist, it's how much you have to gamble on randomness in order to produce the universe in which we now live. Paul Davies, who's a physicist, says, quote, "It seems as though someone has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming." But even that is not the most astounding example of fine-tuning in the universe around us. Roger Penrose, who's a mathematician from Oxford, points out that the one thing people keep forgetting in all this is thermodynamics. And if you've ever had to study thermodynamics, you can understand why people might forget it. But try not to worry too much about what thermodynamics is. Basically, thermodynamics attempts to describe and predict the behaviour of large, complex systems, like a big box of gas, or like the whole of the universe or something. And what it does, you could look at the present properties of the universe, like its temperature and its size and its rate of expansion, and you could calculate what's called the total entropy of the universe, and then you could extrapolate back in time using what's called the second law of thermodynamics and the standard cosmological model for the age of the universe and so on. And then you could work out what was the entropy of the universe at the beginning. Following me? Great. And if you worked out what the entropy of the universe is at the beginning, you could then work out what would be the likelihood of that coming into existence by chance. And the probability of that happening is less than 1 part in 10 to the 123. Now, it's kind of inconceivable to imagine what that number is. If you were writing down 10 to the 40, you've got to write a 1 and then 40 zeros after it. If you're writing down 10 to the 123, you've got to write a 1 and then 10 to the 123 zeros after it. This is an inconceivably vast number. There aren't 10 to the 123 particles or atoms in the universe. There's only about 10 to the 80 atoms in the universe. So just to write down this number, 1 in 10 to the 123, what you'd have to do is you'd have to write a 1 down somewhere. I'll write it on my hand here. And then you have to write a 0 on every single particle in the entire universe. That gives you 10 to the 80 zeros. And then you'd have to do the same thing with another universe, and another universe, and another universe, and keep going until you've done it for as many universes as there were coins in all those piles. And once you've written down that 1, and then all those zeros, you're 0.1% of the way there to writing down the number, which describes the astronomical, no pun intended, improbability of this universe coming into existence by chance. You really do wonder how anybody who studied thermodynamics could imagine that that's what's happened. And of course, it perplexes physicists to think, what could have happened? How could this universe have come into existence by chance? Roger Penrose at least has the courage to point out the staggering, breathtaking improbability of this universe coming into existence by chance. But if you don't believe in the existence of a cosmic mind, or better, a mind that's above and beyond the cosmos, then chance is what you're stuck with, and it looks to me like a very small chance indeed. Something else which reductive materialism has a hard time explaining. The Lord bless you, and bye for now.